Hey there, algebra friends. Welcome to our news section. So we're all done with factoring, and that was awesome. We did a really good job on that. And now we're going to talk about rational expressions. Again, rational, you're thinking of ratio or fraction. And so these are going to be expressions that look a little bit like this, for example. Look at these examples. You see how these are ratios, but they're not normal fractions. They're actually polynomial fractions in a way, right? So you have a polynomial on top and a polynomial on the bottom. So we call those rational expressions. And we need to find ways to reduce them or simplify them. Or we also want to multiply and divide them. Or we're going to try to add and subtract them. And they get pretty crazy. So we're going to go really, really slow. And the most important thing is, because we have rational expressions, that means if you see here, we have lots of denominators here. And the one thing we always have to be careful in math, remember, what can we never, ever, ever divide by? 0, right? So we're going to have to really make sure that none of these denominators equal to 0. So we have to be really careful and try to figure out what numbers, what x values would make those denominators equal to 0. And we're going to make sure we cut them out. You know what we're doing right now? Is we're actually finding something called the domain. That's a very fancy word for just all the x values that you're allowed to plug into a function. So for here, the domain is all numbers for which an algebraic expression is defined. But in your brain, you're thinking, okay, what numbers am I allowed to plug in? And that's my domain. But sometimes to figure out the domain, you also have to figure out, well, what numbers am I not allowed to plug in? What would be bad? And we got to sort of define badness in a second. But that's what domain is. We're trying to figure out, friends, what are we allowed to plug in and what can we not plug in? Because we got to be safe. We don't want to be dividing by 0 or doing anything illegal. That's bad. Well, for example, let's just play for a little bit. Number 1. Can you find the domain of each of these polynomials? Okay, well, let's just think to ourselves. Can we plug in negative numbers? Yeah, I think so. Nothing wrong happens if you plug in negatives. Can we plug in positives? Sure. Yeah, I think that's fine. Can we plug in 0? Sure. You get lots of zeros here when you cube it or multiply by 3. So I feel like we can plug in pretty much anything. We're good to go. There's no problems, which means we can plug in every single number we like. So we can write it as saying from negative infinity to infinity. And that includes pretty much the entire number line. Or an even cooler way of saying it is just saying all real numbers. And we can use this really fancy notation. Ready? Look at this cool little shadow R that I draw. That stands for all real numbers. So all three of these things mean exactly the same. But most times we like to draw this because it makes us feel cool as mathematicians. And it's just a very easy and compact way of saying, I can plug in anything I darn want. So the domain for number 1, all the numbers you can plug in, all real numbers. Now number 2 is a little bit different because this is a square root. We have something inside of a square root. Ooh, okay. So a little alarm comes off my head. Beep, 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 beep. And I remember, shoot, what can we not take the square root of? Let's see, I can take the square root of like 4 and 9 and 16 and even 0. The square root of 0 is just 0, right? Ooh, but then I think, can I take the square root of like negative numbers? No, I don't think so. I don't think I get real numbers out of that. And we'll talk a little bit later about what kind of numbers pop out when you try to take the square root of a negative. Ah, okay. So the square root of a negative is bad. We got to be really careful. That means whatever is inside our radical here, x minus 2, has to be either positive or 0. So why don't we make that a positive or 0 number? So what I'll do is I'm going to try to find all the x minus 2 that are going to be either positive or 0. So I write it like that. All right? We can't have x minus 2 to be less than 0, right? That would be negative. So I'll do all the others. All right, let's just solve this. Solve for x. X, therefore, if we add 2 to both sides, x must be greater than or equal to 2. That means every number greater than or equal to 2 would be legit. Let's test it out. What if we plug in a number greater than or equal to 2? Like 15 or something. All right, let's plug in 15 here into our polynomial. 15 minus 2 is a positive number. Square root? Yeah, we're good. Let's pick a number that's actually illegal. What would be a number that's not greater than or equal to 2? How about 1? Let's try to plug 1. If I plug 1 in here, I get the square root of 1 minus 2, which is, we We are not happy about that, right? So we're right. Yeah, the domain would be all numbers x greater than or equal to 2. A lot of times we use the inequality. We can also say with interval notation from bracket, because we include 2, all the way positive. That's another way to do it too. Either answer is great. Okay, so it looks like square roots are a little scary, so we have to be really careful with square roots. Number 3 has another problem, we already sort of talked about at the beginning, is the fact that I don't want my denominator to equal 0. We have to be really careful. So if you ever see a fraction where x is in the denominator, we got to be really careful not to plug in a value for x that would make the whole denominator equal to 0. So what we could do is, why don't we, I know it sounds dangerous, but I'm actually going to set it equal to 0. And then I'm going to cut those numbers out. So let's pretend. What would make the denominator equal to 0? Let's find out. Let's solve x minus 3 equals 0. Add 3. Cool. So it looks like the number 3 is going to make the denominator 0. Ooh, so do we want that number? Heck no, because that would make the denominator 0. So the domain here would be pretty much x doesn't equal 3. That means all real numbers are awesome, but just not 3. Now again, the way we wrote it, this domain is fine. If you want to write it using interval notation, we just got to say from every single number way far left up to 3, but not including it. And then we're going to add to that using the little union symbol. And then we're just not going to take 3. So we're going to start again at 3 and go far off to infinity. But honestly, I'm okay with writing it this way. And this way. And on number 1, this way is fine. So did you notice we came up with 2 problems, and I'll kind of refer to those problems as danger zones, so that when you see this danger zone, you know that you have to deal with it in some unusual manner. So the first danger zone we saw, like in number 2, was a square root, or really any kind of even root. If you see an even root, we got to be careful because we can't take the square root of a negative. That's bad. So what do? Here's your step. Write this down. You're going to write the expression inside the radical and set it greater than or equal to 0. Okay? And then solve. Solve for x. That's your domain. That's your answer. So if you see a square root, rip that expression out. Up on number 2 up above, it was x minus 2. See how we did it? We said x minus 2 has to be greater than or equal to 0, and we solved. Done. All right, the other danger zone we have to be careful of is you have a fraction with x in the denominator. If you don't have x in the denominator, say like x minus 4 over 3, that's actually safe. Can you see why? Can you see how the denominator can never equal 0, right? Because it's 3. It's just 3. It's not going to ever be 0, so we're not worried about it. Once you put an x in the denominator, then we get a little shaky. So that's when we get careful. Be careful. So see what we did? We set the denominator equal to 0, and then we cut it out. So like in number 3, we set the entire denominator, well, for us, we set it equal to 0. We found our answers, and then we cut them out. If you want to, from step 1, if you want to set the entire denominator just not equal to 0, that would work too. Watch. Let's take number 3. Let's set the denominator not equal to 0, because I don't want the denominator to equal 0. Okay, we'll solve it, but we'll just keep that not equal to there. Add 3. And there you go. That works too. Either way is fine. Either set it equal to 0 and then cut out your answers, or just right away set it not equal to 0 and solve. All right, why don't you try number 1 and 2, pause the video for me. If you have a danger zone, deal with it accordingly, but if you don't, it's just all real numbers. All right, good luck. All right, friends, I look at number 1. Let's find the domain. What x values am I allowed to plug in? All right, let's do a little check here. Do I have a radical, any kind of square root? No, I don't. I'm okay. Ooh, do I have a fraction with an x in the denominator? Yes, I do. So big alarm there in your head. That's a danger zone. So what do? We're going to set the denominator equal to 0 and find out. Let's solve for x and figure out what x value is going to make that equal to 0. And it turns out if you solve for x, you're going to get x equals negative 1/2, negative 1 over 2. That's the x that's going to make that bottom 0. Do we want it? No. So the domain is all x is not equal to negative 1/2. And you can leave it like that. That's a fine answer for a domain. That just implies that everything else is legal, just not the single number of 1/2, negative. All right, number 2. Did you see the danger zone here? You've got a square root. Be careful. So let's tread lightly. Let's rip this out. Rip out the expression. You don't need the radical. You just need to know that this expression cannot be negative. So let's set it greater than or equal to 0. Those are the kind of numbers that we want inside our radical, friends. Okay, let's solve. That's going to be a little sneaky. Let's subtract 6. And we get minus 6. Now I need that x by itself, so I need to divide by -1. But this is really important. Do you see what's going to happen, friends? Do you remember? When you multiply or divide by a negative in an inequality, what happens to him? He flips. Did you catch that? Good for you. That means positive x is now less than or equal to a positive 6. Flip your sign when you multiply or divide by a negative in an inequality. And that's my final answer. I can leave it just like that. That means all values less than or equal to 6 would be legal. And if you ever want to double check, am I right? Did I get this right? What we can do is, let's pick a value that's not in your answer. For example, pick a number that's not less than or equal to 6. I'll pick 10. Let's plug it in. Ooh, do you see that? How about the square root of 6 minus 10? Do you see what's going to happen? I got a square root of a negative. We don't want that. So our answer is beautiful. Okay, so that's how you find the basic domain. But we're going to be doing a lot, and because we're in rational expression land, our domains will be pretty much like we did here for number 1, making the denominator equal to 0 and solving. Okay, so now that we're done with that, let's actually get into rational expressions. Again, rational expression is a fraction because it's a ratio, or another word would be a quotient for division, of basically two polynomials. And it's looking complicated, so it'd be really good if we could figure out how to simplify them. How can we reduce them so that they're easy to play with, easier to plug in values? Well, to simplify, what you basically have to do is you need to divide out anything that's in common. Any common factors. But be careful. If we have something like this, it's really tempting, folks. Do you see this? Oh, look at that. I've got the same. I can cancel them. Get out. And I'm left with a -2 on top and a 4 on the bottom. No. We cannot do that. We can only cancel factors, meaning things that are being multiplied or divided. The x squareds are being added and subtracted on the top and bottom, so we can't cancel it out. Be very careful. That's very, very illegal in math. So what we're going to have to do is we're going to have to factor. That's our big, big star for today. The first step for these is to factor the top and factor the bottom. And then you can cancel any factors that you have in common in the numerator and denominator. So factor, factor, factor. Look at all these stars because factoring is so important. And along the way, we're going to talk about the domain as well. So like I said, for example, 2 times x over 4. We can reduce that and simplify it because you see here we have only multiplication and division. We don't have any addition or subtraction. So look what I can do. I can actually take the 2x over 4 and I can divide out a common factor. Now there's no x's on the bottom, so I can't do anything with the x, but can you see that I can divide the 2 and the 4 by a 2? So I'd be left with a 1 on top and the 2 on the bottom. So this simplifies to 1x over 2. Good, there you go. Ooh, so look at the second one over here. It looks like, I see a 6, I see a 3. That's a 1 and a 2. No, I can't do that. Cancel, 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 cancel. Why? Because of this little symbol right here, because there's addition. If it was multiplication, what if I changed it to 6 times x over 3? Could you simplify? Oh, sure. But because this was addition, we could not do it. So is there anything we can do? No. There's nothing in common with the factor on top, which is x plus 6, and the factor on bottom, even though it's tempting. So be careful. There's nothing to do here. All right, let's play. So let's try to simplify each of these polynomials into its simplest form, which again means factoring, but off to the side, we also have to do domain. So when are we going to do that? Okay, let's figure it out. Step 1. I'm going to put my steps over here. Step 1, let's factor everything. Factor top and bottom. All right, should we try that with number 1? All right, looks like a typical trinomial. Do we have a GCF? No. Do we have an A value that's 1? Yes, okay, so that's not too bad. That factors in, let's see, I need 2 numbers to multiply to give you -12 and add to give you 4. How about plus 6 minus 2? Did you get that too? Plus 6 and minus 2 work. Okay, how about the bottom? Can we factor this? Sure, how about just a normal GCF? Let's take out a 3. Leftovers, x minus 2. Okay, big stop. Stop right here, folks. After you factor, stop, because now let's do domain. Let's figure out what x values that we are allowed and not allowed to plug in, okay? Before you cancel anything, do domain first. Please, 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 do domain before you cancel. Okay, well, let's look. We have a denominator, of course, right? So let's try to figure out where does that denominator equal 0. So let's solve that little piece. Where does x minus 2 equal 0? And it's going to be at x equals 2. And do we want it? No. So your domain over here is all x values not equal to 2. Okay, you need to do that for these problems, folks. So even when you simplify, it might not look like that 2 is illegal anymore, but if it's illegal, if it's bad in the beginning, it's bad for the whole problem. All right, step 2 is done. Now, step 3. Now we can cancel or divide out common factors. And by factors, we mean the parentheses. Look what parentheses we have on common, top and bottom. And if you need a little space, maybe it's easier to rewrite it. I'll do that over here. This friend really, really turned into this. Okay, do you see anything that I have on common, top and bottom? Yeah, I have x minus 2, right? And because this is all multiplication and division, I can destroy them and cancel it out. The x plus 6 and the 3? Nope, we learned on the previous page, actually, that same expression. I can't do anything with it. So this would be my final answer. I'll put it over here on the right side. Final answer, x plus 6 over 3. That is fully simplified. And I've got my domain over here. Notice that our answer here, x plus 6 over 3, it looks like the domain's all real numbers, right? There's no problems. There's no x in the denominator. But remember, if 2 was a problem over here from the beginning, it's always a problem. So it's really important that we write the domain, because I still can't really plug 2 into this. Even though it looks like I can, I really can't. He was bad from the beginning. He's bad for the whole problem. Okay, so step 1, factor top and bottom. Step 2, stop and do domain before you move on. And then step 3, it's so tempting to do step 3 first. Let's cancel first, but then you might miss some domain stuff. Okay, let's try the second and third one. If you feel comfy, go ahead and try it on your own, and we'll check back. All right, number 2 here. Let's factor out. Let's see, I think I have an x in common. So I have x squared minus 4. Ooh, that's the same thing as the difference of squares. Did you see that? X plus 2 times x minus 2. Okay, on the bottom, looks just like a typical trinomial. A is 1. So I'm just thinking of two numbers that multiply to give me negative 2 and add to give me 1. How about 2 and negative 1? All right. So I think this thing is fully factored. Do you think so? I do too. So let's stop. Let's stop and do domain. Okay, try to think. Where does the denominator equal 0? And you can start to see that it's sort of just like solving each parentheses. So I'm going to say the domain up here, D for domain. The domain, x cannot equal, well, what would make that first parentheses? Negative 2. And, how about the second parentheses? 1. There we go. So my domain are all x values. I can plug in anything I darn please. I just can't plug in negative 2 or 1. And even after I simplify, no matter what, I still can't plug those in. All right, let's take a look, friends. Is there anything that you see on top or bottom here that we can cancel out? That's exactly the same. Ooh, I see the x plus 2s. You see that? Let's make a noise. Sweet. Is there anything else? Oh, there's x's, but it's not the exact same on top and bottom, so I can't destroy them. What's left? On top, the x that was just hanging out by himself, and x minus 2, and then just the x minus 1 on the bottom. Okay, that's my final answer. Beautifully simplified, and my domain is there to help me out too. How'd you do? All right, the last one here. This one's kind of hard because the top is sort of out of order, and the bottom is hard because there's no GCF, and the a value here is not 1, so it's going to be kind of tricky. All right. Well, I'll be honest with you. I don't like seeing an x squared that's negative. That just hurts my brain. How do I deal with that? So let me put it actually in standard form first. So that would be negative x squared plus x plus 12. I'll do that. That negative is still there. So why don't we consider it a GCF? Why don't I factor out a negative 1 from here, and that'll make it a little bit easier for me. That would give me a positive x squared. Okay, now watch out. A negative x, and watch out, a negative 12. Okay, that makes me feel a little bit better. I can factor that, but I just have to keep that negative 1 on the outside. Okay, so then we have negative 1. This is just a typical trinomial. This is going to be x minus 4x plus 3. Do you see that? Okay, the bottom. Now the bottom one, let's see. Let's go play with them over here. This doesn't have a GCF, so we have to think about grouping, right? So I'm going to give you a minute. Can you try to group it? Rewrite it into 4 terms. You know how to do this now. You guys are awesome at this. And try to finally factor it. Good luck. Okay, if you did it right, this should be your final answer after all the grouping. Okay, because you guys are really good at grouping and doing the 4 terms and doing trinomials with the a not equal to 1. I'm not going to show that because you guys, again, are really, really good at that. But there's your final answer. Let's put that down here in the denominator. Okay, I really want to cancel, but stop. Let's do domain. Let's do domain first. Okay, let's look at the denominator. Where does that equal 0? Okay, this part equals 0. If you set it equal to 0, you're going to get actually x equals a half, 1 over 2. So we're going to say x can't equal 1 over 2 from the first parentheses. And then from the second one, it cannot equal positive 4. All right, did domain first. Now let's look and see. Now again, look and see. Everything is being multiplied and divided, right? So we can cancel anything that we see is exactly the same because they're being multiplied and divided. So I see a minus 4, x minus 4. Get out. Gone. And I think that's it. Final answer. How about negative x plus 3 is on the top. On the bottom, just 2x minus 1. Final answer with my domain included on top. Good. How'd you do, folks? Pretty cool, right? It's neat that you use a lot of your previous factoring skills to help solve these. Now, the next part is actually really, really cool because all you have to do is multiply and divide. It's basically like multiplying and dividing fractions, right? When you multiply fractions, you just multiply across the top. Remember, when you divide fractions, that's the same thing as multiplying by the reciprocal, right? Okay, so the same idea is happening here. But now that they're rational expressions, we just, again, have to factor like mad. So here, today, we're going to do a little bit of multiplying and dividing. Again, starting point, step 1, factor everything. And I mean everything, like the tops and all the bottoms and everything. So that's going to take a little time to just factor everything. And then after you factor everything, before you cancel, remember what we have to do next? Next, you're going to do your domain. And then you can do all your dividing and canceling out. Okay? So it's just like before, but we're just going to add one step that we have to now multiply or divide when we're all done. Okay? Why don't you pause the video, and why don't you try to factor everything, all the tops and the bottoms, and we'll come back in a second, and we'll check our answers, do domain, and continue. Okay, see you soon. Okay, let's check how your dividing went. This top left one, you had to do grouping. Did you get? How about, I think this would be probably a 3 and a 2, I would say. So how about a plus 3 minus 2? And again, I should always check by foiling, and I noticed that if I foiled that really quick, it would actually be the opposite. So how about 2x minus 3 and x plus 2? So it's always good to just check your answers by a quick mental foil, or go ahead and write it out to see if you do, how you do. Okay, this bottom one's just a normal trinomial, not too bad. So how about plus 5 minus 1? Up here in the top right, we have a GCF. And then after you did the GCF, did you get x minus 2, x minus 1? And on the bottom, we have another GCF 2x. And after you're left with that, you're just left with basically just a 2x minus 3. Okay, I see a lot of things that I could maybe cancel, but we have to do domain first. And remember, domain is going to be all the denominators, which means him and her and him and her. Okay, if there's any doubles, we only have to do it once, but actually all 4 of these are different, so we have to find the domain for each of these. Ready? What x value would make each of those 0? Okay, just moving left to right, x plus 5 would give me negative 5. So it can't be negative 5. Next one, can't be 1. 2x, where does 2x equal 0? Well, that's when x equals 0, right? Okay, so we can't have 0. And the last one, if you set that 2x minus 3 and solved equal to 0, you would get 1.5 or 3/2. Okay, so let's do our domain first. Done. Okay, now there's 2 ways to cancel these, folks. You can either go ahead and just multiply all the way across because they're fractions, like we did in the example, and then cancel top and bottom. Or do you notice that anything that's on top, anything that's on the bottom, no matter where it is, if you see the same thing on any top and any bottom, you can cancel them out. What I mean is not just top and bottom canceling, but also diagonal. We can actually cancel these 2 friends, because if we did multiply, that 2x minus 3 on top would eventually be on the entire top, and that 2x minus 3 on the bottom would eventually be on the entire bottom. So you do have them above each other. So what I'm saying is, you can actually either cancel up and down, or we can actually cancel diagonal if you see it. So the 2x minus 3 is poosh, poof, gone. Do you notice I have the x minus 1 diagonally? So get out, gone. Now it looks like we're just about done, except do you notice I have these 2 friends? So we can cancel because that is a single factor. But what I'm going to cancel is not the 2's. I'm going to cancel the x. So the x is gone and the x is gone, leaving me with a 2. Okay, ready? What the heck is left after all of that? Let's find out. Look at your numerator. What did you not cancel? How about x plus 2 and an x minus 2? Cool. On the bottom, there's a 2 way over here. So I'm going to put him in the front as like a coefficient, but the 2 is left. And the only thing on the bottom left would be x plus 5. And there's your final answer. That's kind of fun. I love the canceling part. You're just doing factoring. Whatever you see top and bottom, you're just going to cancel. But don't forget your domain in between before you cancel, friends. Great job. Let's find one where you have to divide, like this one. Ooh. Ooh, ooh, ooh. Okay. Well, if you want to, first step before you factor, if you want to, you can change the dividing by a fraction into multiplying by the reciprocal. So if you want, you can switch them and do that first. That's fine. Or if you want to stick with our guns, what we did before is, again, we just factored everything and we did domain, and then we'll switch at the end. Okay, I think I'm going to do the second way. I'm going to do factoring first. Let's factor everything, and then we're going to switch it. Okay, so I'm going to take it from this point in the next video. But go ahead and pause the video right now. Go ahead and factor. Let's see if we can get all of our factoring done first, and then we'll come back and meet in the next video and see how this one simplifies. Okay, go ahead and factor, pause, and I'll see you soon. All right, friends, here's what I got. I have a sum and difference of cubes here. How cool. Do you remember? Do you remember? And I also got this numerator here, which didn't factor. That was kind of weird. But maybe we'll figure that out in a second. But there is my complete factoring. Okay? In the next video, we're going to look at domains. We're going to try to figure out what can x not equal to, and then we'll start to destroy these. All right. I'll see you in the next video.